Okay, I think I'm live. Let me share my screen with you all. Yeah, I think my screen is live to everyone. It is visible. Let me again check if I'm visible or not. Just a second, okay? Yeah, I think I'm live. Great. Just a second, guys. Great. I think I'm live. Let me read the problem statement. You are given a binary array contains an integer k. In one operation, you can select a contiguous subarray of length k and flip all its bits. Change every 0 to 1, every 1 to 0. Task is to find the minimum number of such operations required to make the entire array consist of only one. Okay. So the question is, a subarray is going to contain there is a subarray which is going to contain any number of 1 and number of 0. Okay, its length is going to be k, and we need to find the minimum number of such operations to flip all its bits, right? So the entire array consists of only one. Entire array consists of only one. Okay, entire array consists of only one. That means if I'll do the greedy approach, suppose if I'm going to take only for k operations, k subarray, let's suppose. So for k operations, suppose there is 1 1 1 0, k is equal to 4. Okay, and if I'm going to uh, 1 1 1 0, and after that it's something like 0 0 0. There's going to be some edge case because let's take an example. 1 1 0 0 0 1 1 0 1 1 1. Okay, the value of k is equal to 2. I can use any number of, you can select a contiguous subarray of length k. Okay, in one operation I can select a contiguous subarray of length k. Great. So I'll take 0 1 2 3, change to 1. I'll take 3 4. I'll again change 0 to 1. I'll take this one and change to 1. 1 2 3 4. Acha, I have to take a subarray and change 0 to 1, 1 to 0. Okay, okay, great. So, okay, 4 operations are required. 2 3, flip 1 1. Okay, great. Now 4 5. Acha, understood. Okay, okay, okay. 2 3, then 4 5, then like this. Okay, great. So the brute force approach that coming in my mind is, can I use uh, can I select for every k consecutive? I am live, right? Yeah, I am live. I am visible. Yeah. So for I what I can do is, there is going to be k operations, right? So I will select for every k. I will select for each and every possibilities. What I'm trying to tell you is that when I'm going to traverse from left to right, what I'm going to do is, if whenever I see a zero, okay, we like reverse the next k elements to 1. Okay, we will do this until we reach the last position. Okay, so it is impossible to make all the elements 1 if there is a 0 at the end. Okay, if there is a 0 at the end, then it is impossible to make, right? Like, let's take an example of this question only. Suppose there was a 0 at the end, so we cannot like change it to 1, right? Let me show you what I'm trying to tell. It's a very simple approach. Let me write this. I don't need to code this, but still I need to start from the very first index. For int I is equal to 0, I is and I plus plus. Great. What I need to do is, if a double r of I is equal to 0, if this is the case, just flip it. For int j is equal to I, select okay, j is smaller than uh, equal to k, right? Or j is smaller than I plus k, j plus plus. What I need to do is flip all the existing. Okay. Great. This will flip all the year. Okay. Now, uh, after this, I'll just add my answer, increment my answer. Okay. Great. This is what I'm going to do. Also, it is not going to be n. It is going to be n minus k plus 1. Right. If it is going to be 0, do this. After coming out of the loop, we need to check that the last element is going to be 0 or not. Right. So after coming out of this loop, you need to check for int I is equal to for int I is equal to uh, n minus k plus 1, I is smaller than n, I plus plus. So just check that if a double r of I, if any one of them is 0, so return 0 or return minus 1, else return answer. That's it. Let's see if this code is working or not. Yeah, it passed the first test case. Let's take this test case. Okay, let's submit this code and see. This will give me a TLE, of course. Wrong answer. Hmm. It's 0, then only we are changing. Great. Right. J is equal to I, J is smaller than I plus K. Still right, yeah. N minus K plus 1, I is smaller than n, I plus plus. If you do I is 0, return minus 1, or else return answer. Is equal to 0 and is equal to size. I is equal to 0. J is equal to I, J is smaller than I plus 1. J plus plus, it will actually is equal to 1. So plus plus. This code is working completely fine. Let's check for another one. Okay. Like this is going to be a simple approach. You don't know why it does not work. Let's see. Must be a simple bug. Get y equal to 0. Return minus 1. Great. Where is the error coming? Hmm, output is 2, your code output is 4. Uh, if AWR of I is equal to 0, then I only go into this one. I just let's see. This should be a simple bug that I'm overlooking. The only thing that is coming in my mind is uh, I'm sorry. This is the error. I was just do this simple. Nice. Let me submit this code and see if it is working now or not. Yeah. So it is giving me a TLE like I expected it to be, because it is going to be order of O and O of N, and this is O of K. So O of big O of O into K. It is going to give me a TLE, obviously. Now what? What we can do to like give us answer which is not going to give us a TLE? What I am thinking is, so what we are doing is we are basically checking each and every character, right? So for each and every character, what we will do is as soon as I will get a 0, okay, or I will also keep a flag 0, like we used to do in flip bits. So we are going to keep a flag, and it will keep track of the current bit. Is it going to be flipped or not? And if the current, like the flag is 1, so we have to flip the current element, and if the flag is 0, we don't have to do anything. Okay, let me show you what I'm trying to tell you all with the code. Basically what I'm trying to do is, first of all, we'll make a queue. First of all, we are going to make a queue, right? Now int flag is equal to 0. So as soon as for int I is equal to 0, I is smaller than n, like n plus plus. The first thing, if the flag is equal to 0, is equal to we don't have to do anything. If the value of flag is equal to 1, the double r of I mod is equal to 1. Simple. Flip the bit. If the a double r of I is equal to 0, that means we need to flip, right? So what we are to do is, if a double r of I is equal to 0, that means we need to flip, right? So what we are going to do is, we need to flip, but uh, we also need to keep it in mind. No, that is going to be taken care of automatically. So flag is equal to flag. Okay, great. And q dot push 1. Now what? Else, if the AWR of I is not 0, then what? Else q dot push 0. I'll explain why I'm doing this. Okay. Now the main thing. Why am I doing like pushing q and pushing the value of 0 and 1? So why I'm even doing this? Because if suppose, first of all, it will check if I is greater than equal to k. If this is the case, if I is greater than equal to k, don't do anything. Flag is equal to q dot front. Just check for the flag and do q dot pop. Simple. Understood? Now what? Yeah, let's run this code and see if it is working or not. I think this should work. Okay, I'm not incrementing my answer anywhere, right? So simple, increment the value of answer by 1. Yeah, it is working completely fine. Let me submit the code and see. Your output is -1. Its correct output is -1. Your output is 12. Let me see. Okay, I'm not checking for this, right? If e dollar of I is 0, 0, this is equal to 0, and I just write a simple test case like if I plus k, I plus k is greater than n, greater than equal to n, or greater than n, return -1. Simple. Let's see if this test case is working or not. I think this should work now. Yeah, it is working. Let me submit this code and see. Yeah, so simple. We need to keep a queue and check that, and like we used to do in like flip bits, we keep a flag and we will just check that we have to flip it or we don't have to flip it. If we have to flip it, just do this. If we don't have to flip it, we will not flip it. So that's the case. Thank you so much for watching.